So I hope you have understood the topic of quadratic inequalities. So if you are given a quadratic inequality, you can get the interval in which the inequality gets satisfied. What if a quadratic expression is always positive? For example, 2x square minus 3x plus k. If this is greater than or equal to 0 for all x belongs to real numbers, find k. The question is something like this. So here you are not asked to solve this inequality. You are given an unknown in the equation. You are asked to find the possible values of this unknown so that this expression is positive for all x belongs to R. So how do we analyze this? So the analysis is like this. So this quadratic expression is positive for all x belongs to R. That means if you draw the graph of y is equal to 2x square minus 3x plus k, the graph has to be something like this, because this y has to be always positive, always greater than or equal to 0. So you have an equality also. So the graph can at a maximum come this much lower. It cannot go like this, because if it goes like this, then at some points the value of y is negative. I want the value of y to be always greater than or equal to 0. So what is the condition that needs to be applied? So d can be equal to 0 or d can be less than 0. So either of these conditions have to be satisfied. So if a quadratic expression is always greater than or equal to 0, then the condition will be the discriminant is less than or equal to 0. The discriminant will be less than or equal to 0. So this implies discriminant is nothing but b square 9 minus 4ac 8k should be less than or equal to 0. This implies 8k is greater than or equal to 9. This implies k is greater than or equal to 9 by 8. So if k is greater than or equal to 9 by 8, then the discriminant of this expression will be less than or equal to 0. Hence, this expression will always be greater than or equal to 0. So in this way, if an expression is always greater than 0, if an expression ax square plus bx plus c is always greater than 0 for all x belongs to real numbers, then what is the condition which will apply? So if an expression is greater than 0 for all x belongs to R, there are two conditions. The first is a has to be positive, the leading coefficient has to be positive, and the second condition is the discriminant is negative. If an expression is strictly greater than 0, then this has to be the possible graph, and this graph comes only when the discriminant is less than 0 and a is greater than 0. Now ax square plus bx plus c, if it is greater than or equal to 0 for all x belongs to R, then what is the condition? Then a is greater than 0 and d is less than or equal to 0. Because if d is equal to 0, this expression will be equal to 0 at some point. If ax square plus bx plus c is always less than 0 for all x belongs to R, then what is the condition? If this expression is always less than 0, then what is the condition? The graph has to be completely below x-axis. And when will this happen? This happens when a is less than 0 and d is less than 0. So in the question, if a is already less than 0, you just need to apply discriminant less than 0. if it is less than or equal to 0. For all x belongs to real numbers, the condition is that a has to be negative and b has to be less than or equal to 0. So these are the 4 conditions. So as you can clearly observe, these are different from what we have discussed in quadratic inequalities. In quadratic inequalities, you will be given an inequality and you will be asked to solve. Here, you are actually given the solution. This is greater than 0 for all x belongs to R. That means you are actually given a solution. You will be asked to find the unknowns in the equation. So if you are asked to find the condition for this inequation having this solution, then you have to apply these conditions. So there are 2 types of questions in inequalities. First is you will be given an inequality and you will be asked to solve. If you are given such type of question, what you do is you make the leading coefficient as positive first, and then between the roots the expression is negative, outside the roots the expression is positive. If you remember this much, that will be enough. Next, if an inequality is valid for all x belongs to R, then you have some conditions. So you need to remember these conditions. If you remember the graphs, these conditions are very straightforward. If an expression is always positive, that means the graph has to lie completely above x-axis. If an expression is always negative, the graph has to lie completely below x-axis. So this is about the topic of what if the quadratic expression is always positive. So let us take some examples and see how to apply these conditions.